Science Beetle.
Let me go ahead and provide you with a second example so that you can practice yet again. And I encourage you to go ahead and stop the video once I write the problem down, and then that way you have an opportunity to figure out what the empirical formula is going to be. So in this particular compound, we have a compound X. And so compound X is composed of 78.3% barium and 21.7% fluorine. Determine the empirical formula. So go ahead and pause the video here and then work it out and see if you come up with the same answer that we come up here. And so I'm going to go ahead and change my color to blue. Go ahead and pause and unpause it when you're ready to go. Okay, so let's continue. So look at the information we've got. We've got 78.3% barium and 21.7% fluorine. So let's go ahead and take those numbers. 78.3 barium, and the symbol for barium is Ba. And then we've got 21.7% fluorine, and the symbol for fluorine is F. And this is a percentage up there for barium. And since I know here, if I add these two together, I do come up with 100%, I'm just going to go ahead and erase this for now, but I'm just going to go ahead and convert these to grams. So I actually have 78.3 grams of barium, and I've got here 21.7 grams of fluorine. The next step that I want to go ahead and do is I'm going to go ahead and divide the barium number. I'm going to take 78.3 grams of barium, and I'm going to go ahead and divide that by the atomic mass of barium, and the atomic mass of barium is 137 grams per mole. And I'm going to take the 21.7 grams of fluorine and divide it by the atomic mass of fluorine, which is 19 grams per mole. The grams cancel in both cases. Okay. And what I'm left with here is going to be the number of moles of the barium and the fluorine respectively. So the top number here, if I go ahead and take 78.3 and I divide that by 137, that's going to give me 0.571 moles of barium. And the bottom number here, 21.7 divided by 19, will give me 1.142 moles of fluorine. I ask myself, which one of these two is the smaller number? That number is obviously going to be the number for barium. So what I'm going to do is I'm going to divide both of these mole amounts by the mole number of barium that we calculated. So I'm going to take 0.571, I'm going to divide it by 0.571, and do the same thing to the fluorine mole number, or the mole amount. So I'm going to take 1.142 and divide it by 0.571. In the top case, I get a number of 1. In the bottom case, if I take 1.142 and I divide it by 0.0571, I get, let me just do that again, 1.142 divided by 0.0571. 1.142 divided by 0.571 gives me 2. And so again, what these numbers represent here, in the 1 and in the 2, it tells you the relative number of atoms present. The 1 is essentially going to give you the number of atoms of barium, and the 2 is going to tell you the number of atoms of fluorine. So if I take this information here and rewrite it, the formula that I should get, and I'm going to go ahead and write this in red. Since I know that barium is the cation, in other words, it's going to be positive and the fluorine is going to be minus. Cation always goes first in the empirical formula. So barium is going to go first, and I've got only one atom of barium, but I've got fluorine, and since I've got 2 fluorines, that is represented with a subscript of 2. So the empirical formula for a compound composed of 78.3% barium and 21.7% fluorine is BaF2. Hopefully you found that helpful. Go ahead and review this again if you need to in order to practice how to determine the empirical formula. But keep in mind that this process here is just the reverse process that you use to find the percent composition that you learned in the previous lesson. Go ahead and subscribe us, and we'll see you soon.